Hey guys, so we're just moving on here. We are trying to create a sine function given the amplitude, period, and vertical shift. You keep seeing something about a phase shift, but we have not talked about that yet. Okay, so phase shift is something else, so just don't worry about that for right now. If you remember, the parent function for sine would be something like f of x equals a times the sine of b x and then plus d. So from there, remember A stands for amplitude, B affects the period, and D represents a vertical shift. So our amplitude is 1/5, making this become f of x equals 1/5 sine of, and the period affects, the B value affects the period. So we're going to worry about that in just a second. And then the vertical shift is just up 15. So hopefully you're seeing that it's just a plus 15 on the end. So again, the reason I skipped the B value is because it's a little bit more complicated than just simply plugging it in. The period, remember, is equal to 2 pi divided by B. So when I keep saying B affects the period, that's what I mean. So what that turns into is we need to solve for b. So lots of different ways you can do this. Since there's an equal sign, we can cross multiply, or we could multiply by b on both sides and then multiply by the reciprocal of pi over 10. I'm just going to go ahead and cross multiply because it seems like a lot of people are comfortable with that, giving me b times pi equal to 10 times 2 pi, which would be 20 pi. From there, I would try to get b all by itself, so I would divide by pi on both sides, leaving me with b equals 20, giving me my final answer of um, f of x equals 1/5 sine of 20x plus 15. The important thing to notice is that there is not a phase shift yet, and there was no reflection because there was no negative out front.